Okay. So today we'll cover section 2.3. There it is. And this is on As You Learn with the week 2 material. The first problem says to solve by graphing. Now I didn't put solving by graphing on the test because if I have you solve by hand, maybe I could put it with the Desmos though. It's not on, maybe I will. See, I'm kind of torn. I think my test is a little bit long and I don't want to take some problems out. But what I was thinking is there's 3 problems that use technology like the computer, Desmos, or Excel. And so I was thinking of making those 3 take home. So maybe I would put this there because then you could graph on Desmos and I know you know how to graph it then and find the point. So I think there might be a part that's take home, just a couple problems, and they'll be the ones that use the technology, so then you don't need to go into different screens. What happened when I taught another class online, students were having trouble. For instance, they needed to bring up Excel, but then if your computer's running slower because it's already using its camera and you have the test up, it moves slower and you only have 50 minutes. And so the things that have to go to other websites, I think I will make take home. That way then you're just bringing up the Word document and using your paper and you don't need to do anything else on the computer that would slow you down. And so I might put one of those on there then on the take home part. That way I know you're graphing properly. So I'm going to bring that back up. So what we want to do then in order to graph it, we can use Desmos. It's the same one we used for the scatter plot, desmos.com, and graphing calculator. Then I'm going to shrink this so that we can see the problem. Get over here. Now the scatter plot, we had to go under the 3 lines, the 3 bars, and go to statistics. For a straight line, you just plug it in right here. It's already here. And so we would plug for part 1a, y equals 3x minus 12. Y equals 3x minus 12. And then hit enter. And it graphs the line for you. Then go to the one below it, y equals 4x plus 2. Y equals 4x plus 2. Now, when you're solving a system of equations, you want to see where they intersect. And notice it's not showing on my graph. But you can zoom. You want to zoom out until we find it. Notice it's right here. Where the 2 intersect are at negative 14, negative 54. So that would be our point. X is a negative 14 and Y is a negative 54. So you just type both equations and then see where they intersect. Any questions on that? How many questions? Normally my exams have around 11 to 13 questions. It just depends. Sometimes it might have more than one part, so then I might go less. but some of them are, is this a function? And it'll have a picture of a graph, or is a parabola a function? Things like that would only take hopefully a couple seconds. So short ones like that might not take as long, so there could be more, but usually I have around 13. It's a lucky number. I'll know exactly though on Monday. Any questions on this one? So if this was on a take home, then you would either take a picture of this or download it. You can share it. You can send it to yourself and then attach it. Let's try the next one. So part 1b, y equals 2x plus 7. 2x plus 7 and 2x minus 5. What do we notice about the two lines? They're parallel. They never intersect. When you have two lines that the slope is the same, notice the slope's 2 for both of them, then they're growing at the same amount, so they never intersect. Parallel lines, no solution. So if two lines are parallel, they have the same slope. So these two, this would be no solution. I'm going to show you one more. Let's see. If we have, keep the first one, and then 2y equals 4x plus 14. Notice they're on top of each other. They're the same line. Notice if we take the second line and divide it by 2, we have the first one. And that's why I always have you solve for y, because then they're all in simplest form. Because this equation is not wrong, it's just in a different form. And so if I have you solve for y, they're all in simplest form. But when they land on top of each other, that's the same line. It's infinitely many solutions. So if they're parallel, it's no solution. If they land on top of each other, it's infinitely many solutions. Any questions on that? Okay, so that's all that there is to graphing a straight line on here. The second one is solving by substitution. When you have two equations, you can substitute one equation into the other. So we have x equals 5y plus 12 and 3x plus 4y equals a negative 2. This is a nice equation for substitution because it's solved for a variable. We can plug the other part in. So you want to get comfortable looking at them so you know when it's easier to use one thing like substitution and elimination for the other. In this case, we can take this and plug it in for x. So we have 3 times, and then in place of x, we're putting 5y plus 12. Then we want to solve for y, so distribute the 3. And so this is something that would be from chapter 1. Combine like terms. Subtract the 36. Now, if you can subtract the 36 without writing it, that's fine. But I do want you to show work. So I want you to show the steps, but moving the 36 over, if you can do that in your head, that's fine, and get a negative 38. And then again, dividing by 19, getting a negative 2. You could just put y equals negative 2. Or divide by 19. So I want to see your steps in the thought process, but like these parts, if you can do that in your head and the dividing by 19, that's fine. So y equals a negative 2, but we have two variables. You have to find both of them. So to find the second one, we're going to plug this in. X equals 5 times a negative 2 plus 12. X equals negative 10 plus 12. And you can have a calculator, it's fine. So you could just plug this into your calculator. So we get the answer 2, negative 2. Any questions on that? Okay. Any questions on this last one? So for the second one, it's not solved for a variable like this one was solved for x. This one's not. So we want to look at it. If we solve this for x, we're going to have to divide by 2, which is going to give me a fraction. If we solve for y, I got to divide by 5, which is going to give me fractions. Let's try the other one. So if we go over here, notice if we solve for x, we're just subtracting this to the other side. We have this decimal, but we're not going to have more fractions. And so I would solve this one for x. Because again, here we're going to have a fraction with a decimal if we divide by 2.5. So this one I would solve for x. So x equals a negative 2.5y plus 3. We can substitute this in for x. Is there any questions on that? So we're going to take this and plug it in for x. Now, if you already started solving it, what are you noticing? Anything? What happens to the y's? If we distribute this, we get a negative 5y plus 6 plus 5y equals 6.
They cancel out.
Exactly. The y's cancel out and leave 6 equal to 6. When it's a true statement, 6 does equal 6. There's infinitely many solutions. These were the same lines. So there was infinitely many solutions. Notice if you multiply this by 2, you get this. They're the same line. If this was not equal, if we had 4 equals 6, then there'd be no solution. So if it's a true statement, there's infinitely many. And one of the other ones we're going to do, there'll be no solution. Any questions on that? So that's substitution. The other one we're going to learn is elimination. And the first one, 3a, x plus 3y equals 5, and 2x plus 4y equals 8. We want to be able to add down and have something drop out. Right now, when we add down x and y, neither one drop out. So one way of looking at it, you could think of it as a common denominator or the smallest number they both divide into. This is a 2 and a 1. They both go into 2. So I can make one positive 2, one negative 2, and my x's will cancel. Well, we could go to the next one and see if it'll be a smaller value, or maybe if it was 3 and negative 3, we wouldn't even have to multiply. We could just add down. Unfortunately, the smallest number that 3 and 4 go into is 12. So that's definitely going to make my numbers bigger because I'd have to make a positive 12 and a negative 12. So I'm going to go with this one. I already have the 2. If I multiply 1 times 2, I will get 2. Now for them to cancel, you need one positive and one negative, so I'm going to multiply by a negative 2. That way then when I add down, my x's will drop out. So multiply the whole equation by a negative 2. Negative 2 times the 1x is a negative 2x. Negative 2 times 3y is a negative 6y equal to negative 2 times 5, negative 10. So I just distributed the negative 2 to each term. And then the other one, since I'm not doing anything, I'm just going to bring it over. Any questions on that part? Notice when you add down, negative 2, positive 2, those x's canceled. When we add these two, we get a negative 2y equal to negative 2. Divide by the negative 2, and we get y equals a positive 1. Any questions? You still need to plug this back to find the x value. You can use either one of them. I would use the first one because x is to the has a 1 as the leading term. So we have x plus 3 times 1 equals 5. X plus 3 equals 5. Subtract the 3. And we get the 0.21. Any questions on that? Three, 3b. Okay. Again, we want to use elimination. So we want to be able to add down and have a variable drop out. And you look at the first one, we can make both of these a 6 because 6 goes into 6 and 3 goes into 6. This one, 4.5 goes into 9. So this one we can make a positive and a negative 9. 6 is smaller, so I'm going to use that one. I already have 6 in the first equation. In the second one, I can multiply by 2 to make it a 6. But remember, it needs to be one positive and one negative. Since the top one's already positive, I'm going to make the bottom negative. Why change both if I could change only one? I'm not changing the top. The bottom, get a negative 6x, a positive 9y, and a negative 12. Did I write them right? Oh, on the handout, this was a negative 6. Which makes that a positive 12. That way it matches the handout if you go back to do them again. In your book, there's a lot of these problems, so if you need more practice, you can do them. And if you're not getting the right answer that's in the book, send me a picture and I'll let you know. So this should have been a negative 6, which makes this a positive 12. Notice the 6x's and the 9y's, they both cancel. So it leaves 0 on this side. 0 equal to 24. That's a false statement, so there's no solution. So it's either no solution when the variables drop out, or many solutions, or you get one answer. Any questions on that? Okay, the next, I have a little definition here. The break-even quantity. When you're talking about breaking even, well, you can read what's on there. It's where a company is no longer at a loss, where they start making money. Didn't spell money right, but. After that number. So if you find the break-even quantity, say it's 10, after you sell 10 units, you'll start making money. Also, if you have revenue and cost function, when you set them equal, that's your break-even quantity. Or if you have profit, you can set it equal to 0, and that's what that's telling you. Most companies, Black Friday is where they break even. That's when, well, right after, that's when they're going to start making money. So they break even the day after Thanksgiving, almost the end of the year before they start making money. Now they have Christmas in July to help get closer and not wait till November. But so your break-even quantity, you set revenue equal to cost or profit equal to 0. Let's look at number 4. A manufacturer of sinks has a total revenue given of R of X equals 76.50x and a cost $2,970 plus 27x. says, find the number of units that gives the break-even product. So to find the break-even quantity, we set them equal. Now we're solving. So we are going to get the x's on the same side by subtracting the 27 over. $49.50. Divide by the 49.50 to get x by itself. So they need to produce and sell 60 units before they break even or before they can start making money. But at 60 units, they no longer owe money out. Any questions on that? Number 5. A certain product has a supply and demand function where the supply is P equals 5Q plus 20. Q is quantity and P is price. Demand is P equals 128 minus 4Q. So this is our supply and this is our demand. If the price is 60, how many units are supplied and how many are demanded? Well, we know price is P, so we're plugging this in for price. So we would subtract the 20. And divide by 5. Does it say what they are? Just units. So at $60, a company will supply 8 units. To see how much the public demands, we put the 60 in, subtract the 128. So we subtract the 128, and then we'll divide by the -4. $17. So if we're going to sell the item for $60, we will supply 8 units and the public will demand 17. Just like the PlayStation 5, they found the highest they could get it so that they would sell the quantity they wanted, and then people still wanted it, so then they can keep putting out more and having them keep selling. If they put too much out there, then they're going to go on sale. This way they can keep the price higher for a longer period of time. So at $60, they will supply 8, but they really need 17 because that's what the public's demanding. Any questions on that? Part B says to find the market equilibrium. Market equilibrium is when your supply and your demand are the same. To find the equilibrium, you set them equal. So we would set both equations, they're already solved for P, just set them equal to each other. We could substitute the one into the other. 5Q plus 20 equals 128 minus 4Q. Add the 4Q over. Subtract the 20. Wait, it should work out. Did I do something wrong? 5Q plus 20, 128 minus 4. Add that over. Oh, I lost the 8. When I brought this down, I put a 0. There we go. So I brought the 128 down, then we subtracted the 20 and got 108, which is divisible by 9. One, 2, 12. So our quantity is 12. To find out what we're going to sell it for, you use either one of the equations. And we're going to sell them for $80. So the amount that we produce and put out there is the amount that's demanded. They're both the same, they're 12, if we sell them for $80. So then there's no surplus left over, there's no people upset because they can't get it. Any questions on that? Now you could have plugged it into either equation. You plug it in 128 minus 4 times 12, you're still going to get 80. So it's a good way at the end of the test on any that were like this, you could go back, plug it into both, and make sure your answers match. Any questions on that? Number 6. If I put this on a test, I would probably write the system of equations, which is what A, B, C, and D do. I would just have it 1, and then I'd put my last question. But this is how it breaks it up on MyMathLab. A concert promoter needs $84,000 from the sale of 2,400 tickets. The promoter charges $30 for some tickets and $45 for others. So we'll let X be the number of $30 tickets. So the number of $30 tickets I let be X, and the number of $45 tickets I let be Y. You should always label your variables. They even told us in part A, if there's X of the $30 tickets and Y of the $45 tickets, write an equation that states the total number of tickets sold is 2,400. So the total number of tickets is this, because X is the number of $30 tickets, Y is the number of $45 tickets. If we add them together, they should equal the total tickets, which was not 45. This one was 2,400. It says it in part A right here, but it also says it at the top. Now the second part wants you to write an expression. This is an equation because it has an equal sign. An expression does not have an equal sign. Write an expression that shows the amount of money received from selling X tickets at $30 each. So if you're selling X tickets at $30 each, if you multiply them, that's how much money you're making, because each one is $30. So 30x gives us the amount of money that the $30 tickets bring in. Likewise for C, write an expression that shows the amount of money received from selling Y tickets at $45 each. That would be 45Y. Any questions on that? Any questions? I was hoping you were looking at the next one, but write an equation that states the total amount received from the sale of $84,000, if the sale is $84,000. So if we write an equation, they gave us the two expressions because this is the amount of money the $30 tickets bring in, and this is the amount the 45. So did you add them together? And that should equal the 84,000. So all of this would be one part of a question. I would just say write the system of equations. And then I would say solve them. Or how much of each ticket is sold to make the $84,000. I wouldn't break this into parts. Now, if we want to solve it, which is what E asks, then you take the two equations, and you can use elimination or substitution. Either one, whichever you prefer. Looking at it, looking at the x's, I can make them both a 30, or I can make the y's 45. So I would multiply this one by a negative 30 so that the x's would cancel. I'd keep this the same, and then negative 30 times x would be a negative 30x. Negative 30 times y would be a negative 30y, equal to 30 times 24, 672. Yeah, 3 zeros. 1, 2, 3. So that when I add down, my x's cancel. 45 minus 30 is 15y equal to, that's 12,000. So y equals 800. So we're selling 800 tickets at, go back up here, y is the $45 tickets. So at $45 each. But we still need to find the $30 tickets. We know that x plus y is 2400. Plug the 800 in. And then subtract the 800. $1,600 at $30 each. Any questions on that? Number 7 is very similar, only it's using an interest rate. This over here. There we go. A woman invests $15,000 in 2 different mutual funds. One that averages 10% and another is 14%. So I'm going to let X be amount at 10% and Y be the amount at 14%. She invested 52,000. And if her average annual return on the 2 mutual funds is 5,720. That's the interest that she made. X and Y are the amount she invested, so X plus Y should equal the total invested. The other one, 5720, is the interest. Until you take the interest, you need to be careful though, you have to write it as a decimal. Any questions so far? Now you could use elimination. We could multiply through by a 0.1, negative 0.1, so that one of them's negative, and add down, or you could substitute. I'm going to multiply by the negative 0.1 so that I have negative 0.1 x minus 0.1 y equals a negative 5200, 5,200. And then I'm going to bring my other part over. Notice that the x's drop. So we have 0.04 equals 520. So we have y is 13,000 and y was the amount at 14%. So they have 30,000 at 14%. To find the other one, use either equation and solve for x. Started looking at the bottom one. There we go. So I used the first one, x plus the 13,000, which is our y, equals 52,000, and then just subtract the 13 over. I think it's easier using this one, definitely quicker. $39. So 39,000 at 10%. Any questions on that? I think there's a couple more. Yeah. I'll do them real quick. Number 8. Well, I won't do 9. I'll set it up. If you watch my Thursday class or just look at the picture, you'll be able to understand number 9. But try it. If you have questions, let me know. But number 8, you have a high value that he sells it at and a low value. And I'm just using letters so we know what they stand for. You could use X and Y. It says the sum of the high and the low price of a share of stock is 83.50. So the sum, H plus L, is 83.50. The difference between the two is 21.88. Difference means to subtract. So when he adds the two highest, the high and the low stock, he gets 83.50. When he subtracts them, he gets 21.88. And we want to know what's the price of the high and the low stock. Now, notice on this one, it's really nice because if you add down, the L's already drop out. So we don't have to work with the equation. So we have 2H equals, and then when we add these, we get, I'm not going to do that in my head, 21.88. Get 105.38. Divide by 2. So his high stock is usually 52.69. To find the low stock, I would use the first equation because it's a positive low one. Subtract the 52.69. And the low price is 30.81. Any questions on that? Okay. The last one I will start it off because I know once I show you the points, you're not going to have any problem with it. But look at Thursday's recordings and I do the problem. Actually, just look at the photo I put up there. I worked it out. But anyways, it's giving points. A retail chain will buy 900 cordless phones. So phones is X and price is Y. So 900 phones at $10 each and 400 at 60. This is the demand. And then it says the wholesaler will supply 700 phones at $30 and 1,400 at $50. That's your supply. So what you want to do is use these 2 points to write an equation for the demand, and then use these two to write an equation for the supply. Then just set them equal to each other to find the market equilibrium. If I gave this on a test, I would give the 2 equations simply because I'll test you somewhere else where you have to write an equation. Because if you made a mistake in this, then you're missing everything. But there's a picture up on As You Learn where I worked this out. There's also a video. And there's one on my math lab like this. Any questions?